the session now, it's called API Management as Code. And it's basically focusing on having a declarative approach on how to handle API artifacts. And I'm going to be talking a little bit about what is this concept of API management as code and the benefits from automation and concepts like GitOps. And hopefully, if we are right on time and the demo gods are with us today, we will be able to see how it works in one kind of implementation. So a little bit more about me. My name is Hugo. I'm part of the Red Hat team that is working on what in the past used to call middleware, now called application services. And I'm a developer advocate specialized in APIs and messaging, event-driven architecture, Sync API, all these new trends. I'm based in Massachusetts area in the East Coast here in the US. And I have more than 25 years working on development in every single part of the process of the development life cycle. And if you want to follow us in Twitter and get more content around this or around APIs in general, development, you can certainly follow us there. As I was saying, we want to talk about APIs and how do we need to how can we do to handle it better? Because APIs, are this contract where you can consume and bring, and you have this nice interface that is standardized and you're supposed to be able to connect to. However, when you only have one API, well, it's kind of simple. When you have 10 APIs, you can still manage. The problem is when suddenly you have a ton of APIs that you need to manage, 100 APIs, 1,000 APIs. So here, how many of you are are API owners? A couple of you? Okay, perfect. So you know that sometimes being able to manage and communicate and socialize your APIs is not simple, it's not trivial. Because most of the time when you think about APIs, a lot of people tend to confuse some of the aspects of what is an API, right? Most of the people in the past, before these efforts on the Open API specification, tend to think that if I have an open HTTP REST endpoint, then I have an API, and that's enough. But we know that it's not the way to do this, right? Because there's a lot of things around that REST endpoint that needs to be taken into account, right? So how do I do security, authentication, version control? How do I handle deprecation of my APIs? How do I handle scalability? And how do I do protection, rate limits, and so. So that's why is it important to remember some things. And one of those is that when we talk about API, even though we were hearing yesterday that there's several definitions of API, the important part is that the I on API stands for interface and not for implementation. So we have been doing a lot of work around how do I take my Spring Boot application, my Node application, my Node.js application, Express application, all the way through these automation mechanisms and how to deploy those artifacts, right? A jar file or a binary file or just a set of applications. But the problem comes when, okay, I have now the service there, it's running, it's deployed on a VM or a Kubernetes service, or this is deployed in Vercel as a Lambda function. But then, what about the implementation? How do I manage that relationship between how to consume that specific REST endpoint? And this is where I was mentioning before that there are a lot of things coming here. So, okay, we have the REST endpoint, but what about the policies? What are the kind of plans that you're going to be enabled for that API? What about the accounts? How do you create them? How do you manage them? How do you change the status of those accounts? Or the applications that are related to those accounts that are requesting API keys or are using certain configuration for single sign-on, OpenID Connect, and such. And what if I'm splitting those services into what we call the actual backend implementation service and an API product where I'm, creating virtualized contracts that are going to be exposing one or just a partial backend service or several backend services wired together. Like I have 3 or 4 downstream services that I would just want to offer as one single unified version of that, of my service. So all of these services, specification, products, those become a nightmare. And more, when we need to manage every single of those artifacts independently and manually. So this is an example of, in our case, within Red Hat, the structure of some of these artifacts within 3-scale, for example. So you can see that there are different types of relations. There are different types of dependencies. So you need to create them in certain order, because if not, you won't be able to do that and such. So it starts to get more complex and more complex and more complex. So this is why we need to have a different approach beyond just doing everything manually on a UI. And this is very important because of this. Your APIs offer no single value until they reach production. And remember, when we are saying APIs, we're really thinking about the contract that is exposing those APIs. Because yeah, we have these phantom and shallow APIs, but we are trying to do things right. We want to offer them through a nice, very well-managed contract. And so we have then, in the one side, our contracts, our APIs artifacts that we need to be able to take to production as soon as possible, so we can get the value of them. And then on the other hand, we have all these different kind of artifacts that we cannot handle just manually. So this is where a new practice, or well, recently raised practice has been coming very useful. And this is the part of DevOps and DevSecOps, and where the idea is to be able to increase the frequency where we are able to deploy, deliver our applications, our artifacts, and in a way that it's repeatable and that it is assuring certain amount of quality. And with DevOps, we have different concepts like continuous integration, where you just build the artifacts, just deploying, and then the continuous delivery, where we are actually making those services available. One of the key elements of the DevOps approach that it is important to take into account is the concept of the operator pattern. So the benefits of the operator pattern for managing APIs is that we can take this approach where we define in a declarative way what is the desired state of my architecture, of my application, or in our case, of my API artifacts. Now that I am able first to be able to write and specify all these different components and what is the final outcome that I want to have, like all the different plans, all the different services, all the different methods, all the different policies implemented. Then there's this second part where we have the concept of a controller or a controller operator that takes that information and then it goes through a process where it defines that, okay, what is what we are requesting the operator to do. Then it takes the view and the pick of the current state of the system where we are going to apply that desired state. And then it has all the logic on all the different processes to be able to act and make that target environment be compliant or be synchronized with the desired state. So basically, it's a process where you do a change in what we call a manifest, and then the operator, the controller, then takes that information and then uses apply. So it's important to have this controller and or operator being able to manage, the things like in what order do we need to create the artifacts, what kind of components do we need to create, where do I need to create them, how to interact with the logic. So most of the times, this operator, in the past, used to be a human doing that. In the case of DevOps, we're trying to automate all those activities into certain logic that then can fulfill this information. And there are different ways to have these operators being created. But the pattern here that we want to follow is this observe, analyze, and then act, and then continuously do that. So there's a change in the manifest, then there's going to be a difference that we need to act up onto. The question here is, okay, I need to have a way to declare where is the desired state, and then the operator will apply everything on my ecosystem. But where is this manifest living? What is the source of truth of this manifest? And this is where then there's a specialization of our DevOps practice that it's called GitOps. And GitOps, the important point is part of the DevOps, but it's taking Git as the source of truth. So the idea is we are going to use our own repository, our own Git repository, to be able to store all these manifests, all this desired state, and then in this case, we are going to be getting all the benefits of treating those artifacts as code. So we are going to be able to allow Git to be able to do the versioning, to be able to do diff, to be able to do this collaborative approach if you're using things like GitHub or GitLab, to be able to go over this. And then the operations, we need to have a workflow where we can then take the information from your Git repository and then being able to feed it to the controller that then will be able to start running processes on top of that. So if we apply the operator pattern and then we say that Git is the source of truth for our API artifacts, then we have this, right? So we have Git, where we are storing our desired state, and then we have this controller operator that will then take this information and then start to do changes in our environment to be starting to deliver, deploy, and configure our applications. Most of the times, obviously, we expect that the target system allows us to have this friendliness to GitOps, where we can use things like APIs, REST APIs, endpoints, or any other type of integration where we don't require a UI to be able to fulfill those tasks, because at the end, the operator it's just software. Now, when we talk about artifacts and APIs in general, then we start to see these two lanes flows. The first one is when we are doing the deployment and the GitOps part of our implementation side, where we have obviously our implementation repository, where we have all this process of having a pipeline, saying perhaps Jenkins or Tekton, and then being able to then create our finally binary. It could be a container image, or it can be just a jar file or a delivery artifact, and put it on the registry. So most of the times you're going to be creating in the Kubernetes space a container image, and it's going to be stored in a container registry, saying perhaps the Docker Hub registry or the internal registry of your organization and such. The thing here is that now we are able to plug into a second phase of your delivery, where you have this API artifacts repository, where you are able to store these manifests that we were talking about. So we should be able to define and describe all these elements that we were mentioning before, like products, application plans, open API specifications, backend services, in this code repository, and then we can have the controller that is doing the continuous delivery, being able to take that information and then push it to our target environment. It could be your Kubernetes service, or it can be your API manager if you're already using some of this, or it can be directly your API gateway. It depends on the implementation details. So in this case, we have both flows running, the integration and the creation of your API implementation, as well as the deployment of your artifacts as part of the single process. Obviously, across this different integration process, you can add all the different elements to verify that your artifacts are compliant, right? You can add then linters, you can also do testing, contract testing, and other kind of implementation. Details of your process can be embedded in this cycle, in this flow. So you are guaranteeing that obviously those artifacts are going to be a successful deploy and it could be consumed by your API consumers. So in this way, you are able to marry the process of the code deployment as well as the contract deployment in one single flow. So we are not having this detached process, and we are able to still get the benefit of this both flows. There are different elements where how you can implement these kind of flows. So I was saying the first thing is you should be able to define in a manifest type all the different artifacts that you want to use them. And then depending on your target system, you can use either a more traditional approach like using things like Terraform or Ansible, more traditional options like Jenkins or other type of components for CI/CD. If you're more on the Kubernetes world, you might be thinking about using things like Tekton, or in the case on the demo I want to show you, it's we are using for the continuous delivery the Argo project, the Argo CD project that is also Kubernetes native. Now, if you're wondering how do I embed these artifacts in this manifest, so there are different approaches and there are different vendors using different scopes. So the main two options that I've seen in the past that people are using, it's two ways. So the first one is obviously embedding things on the OpenAPI specification using the benefits of extensions. So this is how, for example, our friends of Cusk are doing, right? So they have their specification, your OpenAPI specification with the traditional components, and they're using their own extensions where they're defining, okay, I'm going to apply a course policy, and it's going to be accepting these values and this configuration. For the paths, I'm going to do things like validation, and they're adding these components into their OpenAPI. Same thing here. There's another example, adding more extensions to the OpenAPI specification, and then embedding this information here. In my case, I also agree with Keen regarding that perhaps there are certain aspects of your API artifacts that might not be suitable or they're really don't fit on the OpenAPI specification. And I think some other providers also agree with us. And the thing is that they're proposing also to have this manifest independently. If you are in the Kubernetes world, you will see things like the custom resources. And obviously, Kubernetes offers a mechanism to add custom resource definitions to your services. So in this case, we have this from the guys from Solo, and we have a custom resource that is called route table, and then he has this. They have some metadata, and then the specification where we're defining what host we're going to be using, virtual gateways, matchers, etc. A different policy, for example, this is a way to handle in different artifacts, different elements of your API ecosystem. So in this case, this is clearly a policy, and we are seeing also the configuration of the policy. Another example, we have Kong. Kong, they're also using their same approach of having custom resources. In this case, they have this Kong cluster plugin, and here's the configuration. So we are defining here, if it's fault tolerant, the limits, what kind of policies, and so on. Another plugin that is defining information about headers, and so on. In the case of Red Hat, we also have this same approach where we have a manifest that is defining these properties, these capabilities, and it's based on this tree-scale operator. So in this case, we have, again, a resource that is called product, and then we have some specifications, things like name, definition on the different specific metrics, the methods that are going to be mapped to those metrics, and some information about mapping rules to allow or disallow access to certain paths of your path. There's another example here where we are also linking things like application plans. And then this plan means that there's going to be certain limits on the usage for this plan, and it's going to be referencing the hits. So every 300 hits, you're going to be stopped and limited from that application service. So this is a couple of examples. Then, now let's move into a demo part, and we'll try to show you how it looks on a real environment. So let me do a switch here. Cool. Awesome. So I have here different components. So the first thing is I'm having, oops. Looks like didn't like the, okay, cool. So in this case, oh my, what's going on? Okay. In this case, I'm having here my different components where I am deploying my custom resources I was mentioning. So I'm going to be creating a thing that we call the backend. This is basically saying what is the upstream service that I'm going to be using. I have another that is defining my product and how it looks on the system. So these are just YAML files that I have been storing in my Git repo. So you can check that I'm working on a dev branch, and there are other branches like test and main, and those will help me to move forward my information within this with this same repo. And now that I have this information, then I can obviously use and have my pipeline being able to deploy that. So I'm going to assume that my pipeline it worked, and now I'm able to see that my elements were deployed on my namespace. So in this case, I have this namespace called development. And here we have the operator that is running and watching just this namespace. And if I see the operator, it's managing my service. So there are different custom definitions, part of the operator. And we have my TreeScale products. So I have this one that is the same object that I was showing you before in my IDE. And then this is reflected on my system as a product. So if I go to the dashboard, I can see that there's this operator product echo API with its corresponding backend API. There's other environments, like for example, let's act as testing. So in the case of testing, I only have the basic API. We don't have the operated one. Then we can go to our Argo CD environment, where we are going to be seeing that there's these applications that I have been creating that are controlling this deployment of my artifacts. So in this case, I have one that is controlling development, production, and testing. And we can see information here regarding the sync of the artifacts from the repo to the actual environment. So one of the things we can notice here is that it is out of sync because there's a new resource in my development branch that is not existent in the target Kubernetes cluster. So we can see that there's nothing here, and then there's the new value. So we can just say, okay, let's sync it, and then we expect that resource to be created on the application. And then everything's synced, and everything it's running okay. Now we can see the exact same thing for testing, as we were saying before. In the case of testing, if you go to the UI version, you see that there's only the basic API. And we are looking at that, saying, okay, the testing is also missing all these three artifacts. So the good thing about Argo CD in this example is that we can do the manual synchronization of the artifacts, or we can do it automated. So depending on how much you trust your pipeline, you can say, okay, just publish that. If not, you can just wait for somebody to just click the sync. For most of the time, for environments like production, you might want to wait and then have somebody approve and go forward. So what we can do is here, it's also do the sync, and now we're going to sync all these objects in the test environment, and it failed. So let's see if it was just the GitOps. Yeah, no. Okay, well, should be able to sync up and then send the information back to the service. But now let's do some change and see that, for example, in the environment, we have our product API that says, okay, let's go on the application plans. So we were seeing in the past that we had information on the basic and the unlimited plans. So the basic plan has some information regarding limits, right? We're seeing that we have a limit of value of 10 every day. So what we can do is now we can go to our definition on dev space and say, okay, this is the period and this is the definition of my limit. So let's change that because we are going to be adding more values to this. So we can do this and then we can just commit this new value and let's say increase limits. And then when we push this value, we can see that then again the application, we can see just a refresh, and we can see back again that it's out of sync. So now we can go and check, okay, what is going on? Why is it out of sync? And then we can go to this div space, and we can see, okay, there's a change in the value for the application, the basic application plan, and we can see, okay, it's now increased to 100, and we can just sync this information. This will update the manifest that it's running in the OpenShift cluster, and we can see that this is going to be updated. Now it's 100, and so now the operator or the controller is going to read this information, see that there's a difference between the service that it's running and the service that we are, the application plan value that it's actually in the manager, and then the desired value. So if everything goes correctly, we must see that if we refresh this, we should have a new value that reflects now our change, and now we can see that it's 100. So, yeah, we were able to have. We see two aspects of the operator pattern. The first, the one that it's taking information from the Argo CD saying that there's a missing manifest, and then the tree-scale operator that it's saying that, okay, the manifest is different, we need to apply all these changes. Okay, so that was the demo. Let's go and get back to the slides just to wrap up and see if we can have a couple. Okay, let's see. Okay, here it is. Okay, that was the demo. So there are certain questions that you might be asking, and I think we are all doing those kind of questions. So things like, okay, what do you mean by environment, right? I just show you that I have 2 environments running on a single cluster. The names are just the namespace names. So is it an environment, a definition of an API? Is it your tenant if you're using a multi-cluster service? Is it a namespace within OpenShift? It's a full installation. So I say, okay, I have a full-blown installation, full-blown cluster for each one of those, or is it just something more soft kind of defined? There are other questions like, for example, who owns these kind of processes, right? It's the development team that is just in charge of deploying the implementation, or is it, in more complex scenarios, the API owner who's starting to craft and configure this? Because it is more on a technical side, on the platform implementation, we see that sometimes API owners are not willing to go all that in that. But the idea is that when they craft and define the specification, perhaps using aids like the UI, you can just export the manifests that were created in the UI and then just use those as part of your automation process. So that's a way to make it more easy and more approachable. So finally, just to give you a closing points for this session, the idea of handling API artifacts in a declarative way has some points we try to achieve. So first, remember that APIs are more than just implementation, so there's a ton of things around that we also need to manage. I also need to be able to automate and being able to take it to production to get the value. So it's good and helps to have a way to define in a single piece or a single contract, single manifest, what do you want to achieve, how your API should look like. So we see that it could be through the Open API specification, it could be through other kind of resources like Kubernetes custom resources. And by having these definitions and being able to take them and push into automation pipelines and automation flows, then it helps us to scale. It will allow us to make it easier to move from one environment to another and then just deploy everything forward on. So it increases the control of deployments. You can assure that everything is correctly, it's working great, and then you can just move forward and then increase the rate of deployments of your APIs. And it's important to see that it's working from design first and code first. The important thing is that you need to have that manifest somehow. It could be auto-generated from what you already have in your code. That was a demo that we were not able to show. If you already have an Open API specification, there are certain systems that allows you to take that definition and then extract the objects that it manifests from that. And same thing, if you're also obviously doing design first, you will be able to get all that information directly from your contract and then reuse it and available to do things like mocking, like the contract testing and such, right? So if you're doing design first, you can also automate the generation of artifacts like, if you're using CUS, you can see that they can also mock up directly from those manifest. If you're using things like microcs, obviously, you can also do those kind of things, and you can just automate that as part of your pipeline. So this is the key points that I want you to take away. And yeah, if there's any questions, I'm glad to hear them. It could be right now if we have a little bit more time. If not, I'm going to be around in on the hallway in the lobby, and certainly you can just reach out and ask whatever you want. Okay, thank you very much.
When you were showing your cluster there, so Freescale, there's an operator for Freescale, is that correct?
Yes.
And so basically, it's always looking for the state of your basically proxies of its configs. That's what it's constantly doing.
Yeah.
So you might have, let's say, multiple APIs, and they're all proxies through Freescale, and so you're managing the config to get up via Argo, et cetera, et cetera.
Yes.
Okay.
Yes.
And how do you promote that config? Let's say you have dev, SI, production. You have separate repos or tags, or how do you do that?
Yeah. Let me see if I can just switch back to the previous screen, and I can show you the. So yeah. So we have. So one of the things that I was mentioning regarding the environments is that in the case of Argo, we have 3 applications. So one application is defining each one of the environments. This is just a way to mock up for one single cluster. But the idea is that when we have development, we are configuring the space to say, okay, you're going to get information from this repo. This is my manifest repo. And you're going to use the dev tag or the dev branch, where development is happening. And you're going to use the paths where all these Kubernetes resources are stored. In the case of the testing environment or the testing application that Argo CD is configuring, we're saying, okay, now for testing, you need to be watching the test branch. And that's the one that is going to have the source of truth for your environment. And then you can use that in the same case for what we call the production application. You basically go and say, okay, now take the head, in this case, or the master or whatever. And if you can see, there's a different kind of artifact. Like, for example, in this, we only have two artifacts in production. The one that I wanted to show you before is this Open API from URL that is basically, in this case, an Open API specification. This does not exist in production, so that's why we don't have it on the repo.
So what is another question, if you don't mind? What is I guess I missed out, probably slightly,
Oh, I didn't go into details of why using the spec, but in the case of Treescale, you can generate the artifacts manifest based on the spec. So you say, okay, this is the spec, and then I will automatically create the backend service and the front-end service and the mapping rules and things like that that can help you to automatically automate this. Yes, correct. Yes, and that's why, for example, when you are already having a application that is exposing from code first the open API, and you just want to do, generate everything from that, you can just use that approach. And then you say, okay, and actually, if you see the open API specification, it's very simple. It just tells, this is an open API specification, and this is the URL that you're going to use for that open API. And in this case, I'm using the internal service. So I have an application running on that application, and if I go and see the value, it will return me a. So this is locally. So this is the JSON specification, and then based on that, I can just generate everything.
But you could also, can you go back to the other screen, the previous one? So you were showing the manifest, the YAML.
Yeah.
Yeah. So on that URL, you could. I know you use the service cluster that's local. Can you point it to an outside source, for example?
Yes.
You have to configure the networking, whatever, but
yeah, I would say that, for example, if you have a registry where you are storing all your specifications, you should be targeting that one instead, because that's supposed to be the place where you're storing your open APIs.
Thank you.
Okay. Any other question? No? Okay. Well, thank you very much, and I'll see you.